Scalar gives us magnitude only, not direction, and vector gives us both magnitude as well as direction. Plane means it has both x and y coordinate to describe the motion of the object in the plane. Polar vector, the direction of vector is along the direction of motion of object. Motion in plane is nothing but the two-dimensional motion that we describe the position of object using two axes of a coordinate system. Hello everyone, welcome back to a new chapter and a new session. I am Nishmananjama, Faculty of Physics in Vidhyaashram Pre-University College, the Temple of Excellence, Mysuru. A warm welcome to a new session, session 1 on chapter 4, Motion in a Plane. So far in the chapter 3, we studied what is motion in a straight line, motion in one dimension. So here we shall study two-dimensional motion, that is nothing but motion in a plane. Plane means two-dimensional motion. So motion in a plane is also referred to as motion in two dimension, that is nothing but motion in a plane. So in the previous chapter, chapter 3, we studied motion in a straight line. In one-dimensional motion, we studied velocity, speed, acceleration, displacement and instantaneous velocity, instantaneous acceleration and path length. So all these concepts we studied in one dimension. Similarly, we'll study average, acceleration, velocity, instantaneous velocity, projectile motion, circular motion in two dimension, that is motion in a plane. So motion in a plane is referred to as a motion in two dimension. That means, for example, circular motion, projectile motion, etc. Circular, two-dimensional motions. So, when we say two-dimensional motion, consider a table that it has the base, it has the height, it has two axes x and y describe the motion of the object. Consider the example of blackboard. Blackboard has x-axis, also y-axis. So, it is a two-dimensional object. When we say, you can see here, there are three dimensions, 1D, 2D and 3D. Totally there are three dimensions, 1D, 2D and 3D. For example, we have X, Y, Z coordinate system. So, when we talk about one dimension, only one axis of coordinate describe the motion of the object. For example, car moving along X. So, only one axis, that is X, is describing the motion of the object. When we talk about two dimension, we call it as a motion in plane. When we talk about two dimension, two axes X as well as Y describe the motion of the object. Two axes, say for example, you have a table, it has X and it has a Y, and you have an object at some point, say P, this is the origin O. Object is displaced from O to P. So you need two axes X as well as Y to describe the motion of the object P. For example, you have position along Y-axis and time along X-axis. For 1 second, object has moved 2 meter. For 2 seconds, object has moved 3 meter. So when you plot a graph, you will get a straight line. So for each time increases, the position of the object is increasing. The position is shifting from the origin to some point. So you can see, you need to know what is the position of point at some time, say 5 seconds. You want to know what is the position of object P, then you need time as well as position axis X as well as Y axis to describe the position of the object after certain time interval. So when we talk about three dimension, we need all the three coordinates X, Y and Z to describe the motion of the object. That is nothing but, it is not a linear or a plane, it is a motion in space. A bird flying in a sky, it is three dimension. You have to imagine the 3D picture in your mind. So you can see one dimensional, it is a linear motion. Only one axis, that is x-axis, is describing the motion of the object. When you talk about two dimension, a square or a circle, you can consider as an example. We need two axes, say x and y, to describe the motion of the object. When we talk about 3 dimension, so this is a 3D picture. Cube is the example for a 3 dimension. You can see you have 3 coordinates x, y and z to describe the motion of the object in that particular cube. So what is motion? Motion is the change of position of the body with respect to time. There is a change in the position of the body. Car is moving. It is not in rest. There is change in position. Object was initial at origin. It has moved as time increases to certain point P. That means it is under motion. Change of position with respect to time is called motion. So motion in a plane means it is 2-dimensional motion that we consider 2 axes x and y in the coordinate system to describe the motion or change of position of the object. So example, circular motion, projectile motion, etc. So this image of a line, square and cube gives an idea about 1D, 2D and 3D dimensions. So the 3 dimensions, 1D, 2D and 3D, we are concentrating on the 2 dimension. That is nothing but a motion in a plane. You are considering 2 axes to describe the motion of the object. In the previous session, in the chapter 3, we have already studied about 1-dimensional motion. So next, you have scalar and vector. So in the previous session, we have already got a little idea about scalar and vector. So in this chapter, you will get a detailed idea about what is the addition of vectors or scalars, how do you add vectors, multiplication of vector, subtraction of vector. So you'll get a detailed idea about scalars and vector. From the previous session, we have an idea that scalar depends only on magnitude and it is independent of direction. Vector depends on both magnitude and direction. Speed, distance, the example for scalar, displacement, velocity are the example for vector. So physical quantity is classified into scalars and vectors. What do you mean by physical quantities? We have studied in our very first session what is physical quantity. A quantity that can be measured. A measurable quantity is called physical quantity and given in terms of numerical value. For example, what is the length of the pen? It is 10. What is the length of pen? It is 10 what? Meter. So this is your physical quantity and this is your unit to represent this physical quantity. So we have studied in our chapter 2 about units and measurements. How do we assign units to the measured physical quantity? So 10 meter is the length of the pen. So length of the pen is a measurable quantity. You can measure what is the length of the pen, what is the length of the pencil. So all these are measurable quantities and you can measure it and give it in terms of numerical value. So these are called physical quantities. And these physical quantities are divided into scalars and vectors. So what is scalars? It gives you only magnitude. It is independent of direction. And what is vector? Gives us both magnitude and direction. So scalar gives us magnitude only, not direction, and vector gives us both magnitude as well as direction. So example for scalars are mass, length, time, speed, etc., which gives us only the magnitude. So what is the length of the pen? 10 meter. 10 is what? Magnitude. Magnitude is nothing but a numerical value that it gives only magnitude, not the direction. Whether you are giving any direction for length of pen, how did you measure length of pen? Right, left, north, south, any direction? No. Only the numerical value. That is, it gives only magnitude. Hence, length is a scalar quantity. When you talk about vectors, it gives both direction as well as magnitude. For example, displacement, velocity, acceleration. Velocity, for example, a moving car, the velocity of a moving car is 60 km per hour. It is moving towards north. So you're giving the velocity, that is a magnitude 50 km, a numerical value, plus it's moving towards north, plus the direction. Hence, velocity is a vector quantity. For example, consider that you go for a early morning walk of 2 km per hour. You go a early morning walk for 2 km per hour. This 2 km per hour, you go early morning walk of 2 km per hour. It is giving me only magnitude. It's telling a numerical value. Magnitude is nothing but numerical value. You're going 2 km per hour for a walk daily. That means it is a scalar. When you say, I go for a walk daily 2 km per hour towards north or towards south, that means it is giving me magnitude as well as direction. Hence, it is a vector quantity. For example, I have a ball. I'll apply a force. A ball is at rest. I'll apply a force of say 6 Newton. 6 Newton is the force that I have applied to push this ball. For example, to push this ball. What is my 6 Newton? It is the magnitude. Hence, it is a scalar. When I say I have applied 6 Newton of force, so when I push the ball, it moved towards the right or it moves towards the left. I applied 6 Newton of force, it moved towards the right. So, both direction as well as magnitude, that means it is a vector. I hope scalar and vector are clear. Any quantity that can be measured given in terms of numerical value is called physical quantity, and it is broadly classified into scalar and vector. Scalar example is mass, length, time, which gives us only magnitude, not the direction. And vectors is classified into displacement, velocity, acceleration, which gives us both magnitude as well as direction. So next you have representation of a vector. Representation of a vector. What do you mean by vector? It gives us both magnitude and direction. Keep in mind, it is the representation of vector. So consider I have 2 points, A and B. I will join these 2 points with the help of a line from one point A to another point B. So I want to measure what is the length of this line. So length of the line AB. Length of the line AB is 6 centimeter. For example, I measured the length of the line AB. It is 6 centimeter. So, only 6 centimeter is not enough because it's the representation of vector. So, we need direction. So, I'll point an arrow near B. So, which means that length of the line AB is 6 centimeter along AB. That means it is giving me direction along AB from A to B. The arrow is pointing towards B. So it is 6 centimeter. That means any vector is represented by a directed line segment. So this is my directed line segment, which is directing that A is moving towards B. From A to B, we are measuring the length of the line. It is 6 centimeter. So arrow near B gives me direction, and this 6 centimeter gives me length of the line AB. So it is a vector. Arrow at the end that is near the B indicates direction, and length of the line, that is 6 centimeter, represents the magnitude. You have both magnitude and direction, that is vector. So analytically, we represent a vector using an arrow over it. For example, you have a vector A. We represent vector A using an arrow above its head. You have force, for example. F, it is a vector quantity. You represented vector. When you talk about vector, you should put an arrow above its head over it. So this is how we represent a vector, usually using an arrow above its head, we represent vector. For example, you can see force. It is not just F. You have an arrow over it. That means it's a vector. So momentum, it's a vector quantity again. So this is how you represent vector. So magnitude of vector is given by mod of A vector by A vector. This is the magnitude of vector is given by mod of A vector by A vector. So this is the representation of vector. But in few textbook, instead of using arrow above the momentum, for example, they will usually represent it in a capital letter with a bold, with a dark letter, they will mention the vector symbol. And few will use arrow to represent it above its head, but in few textbook you can just see F written in a bold letter. That means it is nothing but a vector. And how do we represent vector? Using a arrow. Throughout when you talk about vectors in this chapter, we represent that using a arrow. This end is your tail and this arrow at the end, this is your head. So if you consider arrow, you use arrow to represent the vector of quantity. So when you use arrow, the one end, this end of the arrow is called tail and this end of the arrow is called head. For example, you have the arrow like this. This arrow end is your head, this end is your tail. So keep in mind, in our all the sessions, we will be mentioning it as tail and head. So don't get confused. So this is about representation of vector. So a directed line segment, it gives the direction and length of the line gives you magnitude. So usually vector is represented using arrow over the quantity, say F above arrow, that means we are talking of a vector quantity. Next we have types of vector. You can see here, vectors are broadly classified into localized or fixed vector, non-localized or free vector, collinear vector, equal vector, negative vectors, unit vectors, orthogonal unit vectors, coplanar vectors, polar vectors, axial vectors and null vectors. Let us individually try to understand what are each of these vectors. So vectors is classified into following types. In that the first one is localized or fixed vectors. So the name itself say it is a fixed. So if you have an arrow, so this is your head and this is your tail. The tail of the arrow is fixed. It is fixed. That is what we call as fixed or localized vector. And non-localized or free vector is just opposite to localized vector. That it is, its tail of the arrow, that is tail is not fixed. That is non-localized or free vector. Then what do you mean by collinear vector? Collinear vector. The vector will have equal or unequal magnitudes but the same direction. It might have equal or unequal magnitude. For example, it might have equal. For example, the arrow, this magnitude is 4 and this magnitude is 7. It might have equal 4, 4 or unequal 4, 7. But the direction of the vector is same. That is collinear vector. Next you have equal vectors. The name itself says equal. When you talk about vectors, it is magnitude and direction. You have equal, that means you should have, if the vector has same magnitude and same direction, it has, for example, it has 4 and it is also 4. Same magnitude and same. It is moving towards right. Same magnitude, same direction is called equal vectors. Next you have negative vectors. So what do you mean by negative vectors? This negative vector is just opposite of collinear. That is the third type of vector. Here they have equal or unequal magnitude but same direction. But in negative vector, you have equal magnitudes but the direction is not same, opposite direction. So that is negative vector. So you have equal magnitude but opposite direction. Both has 5, 5, equal magnitude but the direction is opposite. So you have unit vector. Unit vector, it has unit magnitude. That magnitude is equal to 1. Magnitude is equal to 1. That is unit vector. For example, unit vector, unit magnitude. It has unit magnitude. So, in unit vector, we usually represent the alphabet, that if A using a cap above its head. So, using a cap, we represent the unit vector. Unit vector is a vector which has unit magnitude that it is 1. So, next you have orthogonal unit vector. So, what do you mean by this? If you have 3 coordinate system x, y and z, so each axis has a unit vector. Each axis, each coordinates has a unit vector. Say I cap is a unit vector along x-axis. J cap, we use cap to represent a unit vector. J cap is a unit vector along y-axis and K cap is a unit vector along the z-axis. So, this unit vector along x, y, z is what we call it as orthogonal unit vector. This I cap, J cap and K cap along x, y, z axis, we call it as orthogonal unit vectors. What is coplanar vectors? Collinear is different. What is coplanar? It lies on the 2 plane. So, it lies on the 2 plane. We call it as coplanar vector. Then what is polar vector? Polar vector, the direction of vector is along the direction of motion of object. If the ball is moving towards the right, the direction of vector will also be towards right. So, direction of vector is along the direction of motion of the object. That is what we call it as polar vectors. Then what about axial vectors? The direction is along the rotation of the axis. The direction of vector is along the rotation of the axis. For example, you call angular velocity, angular acceleration, torque are the example for axial vector. The direction is along the rotation of the axis. Then what is null vector? It is also called as zero vector. It is also called as zero vector, null vector or zero vector. That it has an arbitrary direction. It has a arbitrary direction. So, null vector or zero vector, it has zero magnitude. It has zero magnitude and direction is arbitrary. That is null vector. What is coplanar? Vector lying in the same plane is called coplanar vector. I hope you are clear with the types of vectors. So, vector is broadly classified into following types. I hope all the types are clear for you. Next, we have position and displacement vector. What do you mean by position and displacement vector? It is very important to understand what is position, what is displacement. Position and displacement vector. So, to describe a position of an object, I have an object. To describe the position of the object moving in a plane, we need to choose a convenient point, say origin O. So, when we talk about plane, it is 2 dimension, motion in 2 dimension. That means we need 2 axes, say y and x, to represent the motion of the object that we consider. So, when we talk about object moving in a plane, so this is your plane which is 2 dimension. You have 2 axes, x as well as y, to represent the motion of the object. To represent this motion of the object, origin O is very important. Origin must be there to describe the position of object P. So, I have 2 dimension, that is plane. Consider table or board is your plane. It has 2 axes, x and y axis. I have an object P which has moved from the origin to certain distance. So, it was changed its position. That means it is in motion. The object has moved from point O, origin. The 2 line is intersecting at a point O. This is your origin. Origin must be there to describe the motion, the change of position of object P. If origin is not there, how will you tell where to where did the object move? What is the motion? You cannot represent if origin is not there. That's why we consider a convenient point, say origin O. So from origin, a point is moved to P, and from P, again the object or a ball has moved to position P dash. I'll join this line to origin O. So let P and P dash be the position of object at time T and T dash. So when we are talking about position and time, we have studied a graphical representation, position time graph in chapter 3. Please go back and study what is position time graph. So your time is along x-axis and your position x is given along y-axis. So this is your position time graph. This is a position time plane where P and P dash are the position of object. Object is moved, it has changed its position to P and P dash with respect to time T and T dash. So OP, position of vector at time T. OP is the position of vector at time T, and OP is equal to R. OP dash is equal to R dash. So R and R dash are the position vector of OP and OP dash at time T and T dash. So length of R is the magnitude to the vector. Length of R is the magnitude to vector. If object moves from P to P dash, if the object moves from P to P dash, then the vector is known as displacement vector. So object was initially at position P. Now it is displaced. It is moved from P to P dash. This is the final position. This is the initial position. Initial position minus final position is nothing but my displacement vector. So that is position vector and displacement vector. To describe the position of the vector, I have considered a two-dimension motion, that is a plane. Plane means it has both x and y coordinate to describe the motion of the object in the plane. So origin must be there to describe the change of position of the object. So from origin, the object has moved to point P. From point P, it is displaced to point P dash from time T to T dash. So if I join the point OP is equal to position vector R, and OP dash position vector is R dash, and this difference from P to P dash, the object is displaced initial to final position. The difference between initial and final position is nothing but my displacement vector. So this is about position and displacement vector. So next you have equality of vectors. The name itself tells equality of vectors. In the types of vector, we have studied equal vectors. So what is equal vectors? Suppose if you have two vectors A and B, vector represented by arrow above its head. When you have two vectors A and B are equal, they are equal, A is equal to B. They are equal, these two vectors are equal if and only if they have same magnitude and same direction. So look at the examples here. You have three examples, 1, 2 and 3. In this case, you have magnitude is 5. B is also magnitude is 5. So magnitude is equal, but the direction is opposite. It is pointing towards down, it is moving towards up. So A is not equal to B. A vector is not equal to B because they have same magnitude. The numerical value is same, but they are in opposite direction. In the second example, you see, they are in the same direction. They are moving towards up, but the magnitude here is 3, here is 7. So 3 is not equal to 7, right? The magnitude is not equal, but the direction is same. But A is not equal to B. In the third example, the magnitude is 7, 7, for example. The numerical value is same. 7 is equal to 7. The direction is also pointing towards down. Both direction as well as magnitude, both are same. So in the third example, vector A is equal to B. So this is right. These are wrong. Clear? A vector is equal, A is equal to B if and only if it has same magnitude as well as same direction. Even though if it has equal magnitude, opposite direction, same direction, unequal magnitude, they are not called as equal vectors. A is not equal to B. It is only equal if it has same magnitude and if it has same direction. This is about equality of vectors. So, in today's session, we studied what is motion in plane. Motion in plane is nothing but the two-dimensional motion that we describe the position of object using two axes of a coordinate system. Table or a blackboard all has two axes, x and y axis, to describe the position of the object at certain or motion of the object at certain point. So we have three dimensions: 1D, 2D, 3D. So 1D we studied about velocity, acceleration, that is motion in a straight line in the previous chapter. So here we are studying motion in a plane, that is two-dimensional motion. Again we will study what is velocity, scalar, vector in depth in 2D, two dimension. So after that we studied how do we represent the vector using arrow over the head. Using a arrow above the vector, we represent the vector quantity. Vector is specify both magnitude as well as direction. So we usually have a directed line segment to represent the vector. So we studied physical quantities classified into scalar and vector. Scalar depends only on magnitude, independent of direction. Vector gives both direction as well as magnitude. For example, velocity. Scalar example is time, mass, etc. We studied it using an example in today's session. Then we studied what is position vector as well as displacement vector. Then we studied the different types of vector, from localized vector to null vector. We described each vector individually. Then we studied equality of vectors. So the vectors are equal only if it has same direction and same magnitude. Then only we call it as equal vectors. A is equal to B. That's all for today's session. I'll be coming up with more interesting session in motion in a plane. So until then, take care. Have a good day. Thank you.